All right, so let's see. At the beginning of the assessment, I leave you a little space to calculate all of these things. Now, I don't ask you to do it, but of course you have to do all this before you can even start to answer an inclined plane problem. Okay, so 27 degrees is like something like that, right? Here's this block of wood. Okay, 1.40 kilograms. Now, remember that the force of gravity is straight down on this poor guy, right? And then there's this angle here is 27 degrees. Okay, I don't know why I write numbers that way. Okay, remember then that there's a component of gravity that acts down the plane, just like a force acting down the plane. And then there's part of the gravity that is perpendicular to the plane. Okay, this force parallel is mg sine theta. Now it's sine theta because here's the angle, that's the opposite side. So we're doing SOHCAHTOA. This is a 90-degree angle. There's a hypotenuse. So hypotenuse times the sine of the angle gives you this side. Okay, and then this side right here, this perpendicular component of gravity is mg cos theta. And this is what's going to give rise to the reaction force. Okay, so we'll use that here. Okay, so the first thing I want to do is figure out the force parallel, which is mg sine theta. Now, the way to remember this, by the way, is remember that if this angle is 0, you should have no force parallel to the plane, right? And indeed, the sine of 0 is 0, so that's how you remember it. And if you can't remember that, your calculator does, right? So this is 1.4 times 9.81 times sine of 27. So let's bust that out. 4 times 9.81 times sine of 27. Boom, 6.235. Okay, this thing acts always down the plane. It's always there, it's always down the plane. We'll always make it negative. Okay? And now let's figure out our dynamic and static friction forces, right? So the force of friction dynamic is mu dynamic times r, which is, what is it? It's 0.105 times, and then the reaction force is the, so it'll end up being, it's mu dynamic times r, which ends up being mu dynamic times mg cos theta. And that's because this part of the force of gravity is perpendicular to the plane. That's the component perpendicular. Okay. So let's just plug these numbers in. 1.4 times 9.81, and this is cos of 27. Okay. So 0.105 times 1.4 times 9.81 times cos of 27 is I'll say 1.285. Okay, now 4 digits is not actually enough to be off, to be like totally on. We'll only be off by maybe a decimal point if we use these, but that'll be close enough. Okay, and then the maximum force of friction, the static max, okay, which only tells you whether the thing will actually stay on the plane if it's sitting still, is mu static times r, which is going to be mu static times mg cos theta, right? This is mg cos theta, right? So that is 0.22 times 1.4 times 9.81 times cos of 27. Please do me a favor and make sure your calculator is in degrees. All right, so here we go. 0.22 times 1.4 times 9.81 times cos of 27, and that's 2.692. There we go. All right, so these are our players, right? If it's sitting still, this force tries to make it stay on the plane. So if the first question were, will it stay on the plane? You would say, no, it won't stay on the plane because the parallel force acting down the plane is so much bigger than this static force that could try to make it stay on the plane, okay? But these will be our players. This guy opposes, this is the parallel force is always down the plane, right? This force, this 1.285, opposes your sliding. So let's just take a look at some more problems here.